Today I am going to discuss about advantages and disadvantages of nuclear power plant comparing to the other conventional power plant, that is thermal, hydro, and selection of site of the nuclear power plant. Actually, the thermal conventional power plants are thermal, nuclear, and the hydro power plants, and the gas and then diesel power plants. Now, in the thermal power plant, the fuel we are using to generate the power is coal. Nuclear power plant, the fuel we are using is uranium, thorium, and then the plutonium. But maximum they are preferred in the thermal power plant, the uranium, that is uranium 235. In hydro power plant, the power we are generated with the help of water. And the diesel power plant we are using for diesel or petrol. The gas power plant we are using for the natural gas. Actually, in the thermal power plant, it can be constructed nearer to the load center. The nuclear power plant is also constructed nearer to the load center, that is far away from the, somewhat away from the load center. The hydro power plant, wherever the water is available, for the particular places we need to construct for the hydro power plant. And another one, here the transportation facility is available in the thermal power plant, that is both railways as well as for the roadways. In nuclear power plant, the transportation facility is available, but in the hydro power plant, the transportation facility is very, very difficult. And here, in the thermal power plant, the fuel, the coal requirement is more, as well as the water requirement is also huge. But in the nuclear power plant, the fuel requirement is very, very less. Just we are applying little bit of fuel, we can generate the maximum amount of power. And the water requirement is also very, very less. In hydro power plant, it is generated the power with the help of water. That is, the huge quantity of water is required. In the thermal power plant, the land requirement is somewhat more. Land is used for coal storage plant, coal handling plant, hash storage plant, hash handling plant, and the remaining construction of the power generation of the power plant, and so on, etc. But in the nuclear power plant, the fuel requirement is very, very less. The fuel requirement is very, very less. The little bit of fuel we can generate the huge amount of power. The little bit of fuel we can generate the huge amount of power. But in the hydro power plant, with the help of water, we are generating the power. That is, the more quantity of water is required. Here, in this thermal power plant, we can generate it throughout the period in a year, 365 days. The nuclear power plant, we can generate the power throughout the year. But in the hydroelectric power plant, we are generating only in the season, that is the 4 to 6 month period. Suppose if the water is available, the rainfall is maximum, means we can generate the maximum 6 to 8 years. But in the hydroelectric power plant, we are generating the power only in the season, that is the rainy season. And another thing, the thermal power plant used for only base load plant, it is not applicable for the peak load. It is not applicable for the peak load. But the nuclear power plant is applicable for both base as well as for the peak load plant. Both base as well as for the peak load plant. But in the hydroelectric power plant, it is also applicable for both base load as well as for the peak load plant. But based upon the availability of water, we can generate the power. In the rainy season, we are generating the power both base as well as for the peak load. But in the summer season, we can utilize only for the peak load. In summer season, we can utilize only for the peak load. And one more thing, in the thermal power plant, the temperature is maintained from 250 to 500 degrees centigrade. 250 to 500 degrees centigrade. That is, the minimum temperature is 250 degrees centigrade and the maximum temperature is 500 degrees centigrade. In the nuclear power plant, it is also similar to the working base, similar to the thermal power plant. Here also the temperature is 250 to 500 degrees centigrade. 250 to 500 degrees centigrade. And the thermal power plant and nuclear power plant, the working principle is similar. Both the working on the principle of, that is nothing but a Rankine cycle. The both working on the principle of a Rankine cycle. That is for the closed loop operation. Both thermal power plant as well as for the nuclear power plant working on the principle of Rankine cycle. In closed loop operation, we are reheating in the intermediate stages. That is, we are using for the wastage of the steam in the intermediate stages. Due to that, the efficiency is improved. At the same time, the fuel is saved. That fuel we can utilize for the future power generation purpose. That fuel we can utilize for the future power generation purpose. Here in the hydroelectric power plant is working based upon the hydrological cycle. Based upon the hydrological cycle. And in the thermal power plant, the nuclear power plant, the turbine we are using is the steam turbine. Again, here it is for two types. One is for the impulse turbine, another one is for the reaction turbine. But maximum for both the power plant, that is either thermal or nuclear power plant, they are preferred for the impulse turbine. The shaft position is horizontal. In the hydropower plant, based upon the availability of heat, the turbines are classified for three types. One is for Pelton wheel turbine, another one the Francis turbine, and the next one is Kaplan turbine. Kaplan turbine. Based on the available head of water, the turbines are classified for three types. One is for Pelton wheel turbine, another one is for Francis turbine, next one is Kaplan turbine. In Pelton wheel turbine is used for high power generation, Francis turbine is used for medium power generation, and the Kaplan turbine is used for low power generation. Low power generation. Based upon the availability of heat, they are generating the power, and the turbine is also classified for three types. One is for Pelton wheel turbine, Francis turbine, and then Kaplan turbine. The Pelton wheel turbine, there is nothing but the shaft position is horizontal, and Kaplan and then Francis turbine, this is nothing but the medium and low speed turbine. The shaft position is either horizontal or vertical position. The shaft position is either horizontal or vertical position. And one more thing in the thermal power plant, the power generation, it takes 6 to 8 hours period. 6 to 8 hours period. That is, in the boiler furnace, the coal is burning. In that the boiler, the water is converted in the form of steam. The temperature, that is 220 to 250 degrees centigrade or more than 250 degrees centigrade, it takes minimum 6 hours duration. But in the nuclear power plant, just we are applying the fuel, that is uranium, within fraction of second the power is generated. Within fraction of second the power is generated. Similarly, in the hydroelectric power plant, whenever the water strikes the turbine blade, immediately the power generation is started. Immediately the power generation is started. Now, what are the advantages of the nuclear power plant comparing to the other thermal power plant, other conventional power plant, that is either thermal or hydro, gas, and then diesel power plant? What are the advantages of nuclear power plant comparing to the other conventional power plant? Primary, the advantage is the fuel requirement is less. That is, here the fuel we are using is the nuclear power plant, uranium, thorium, and then plutonium. Comparing to the thermal power plant, the fuel requirement is very, very less. Due to that, no need to storage the fuel, the huge quantity like thermal power plant. Here the fuel requirement is very, very less. Just we are applying the little bit of fuel, we can generate the maximum amount of power. That is, amount of fuel requirement is less comparing to the thermal power plants. For that purpose, no need to store for the fuel storage plants. No need to store for the fuel storage. And the running cost is very, very less comparing to the other conventional power plant. The running cost in the sense that is nothing but the fuel utilization. Here we are applying the little bit of fuel, we are generating the maximum amount of power. Due to that, the running cost is also minimized. And fuel requirement is low. Due to that, the transportation cost is also minimized. The transportation cost is also minimized. The transportation cost is also minimized. And no need for the fuel tension. Actually, in the thermal power plant, the huge quantity of the fuel is required. Due to that, regularly we need to import the fuel from the coal mine. But here in the nuclear power plant, the mining center, monthly once or the monthly twice we are importing the fuel. No need to regular transportation. Due to that, the transportation cost is minimized. And comparing to the thermal power plant, the huge amount of the power is generated. The power generation is maximum. And one more advantage, it is used for the both base load as well as for the peak load. And the power generation is also maximum in the nuclear power plant comparing to the thermal power plant. Just suppose the power plant, the capacity is 500 megawatt. The power plant, the capacity is 500 megawatt. Actually, we can generate the maximum power is 482 up to we can generate it for 540 megawatt power. We can generate, that is 480 megawatt to up to 540 we are generating the power. Unfortunately, due to the peak load, now the power generation, that is the base load, only 260 megawatt. Only 260 megawatt. Suddenly, these 260 megawatt raising into 395 megawatt. 395 megawatt. Within a minute, we need to satisfy for the demand. Just we are applying a little bit of fuel, additional amount of the fuel, the uranium, within fraction of second or within a minute, we can satisfy for the demand. We can bring from 260 megawatt into 395 megawatt. It is applicable only in the nuclear power plant. It is not applicable in the thermal power plant. And the nuclear power plant can be constructed nearer to the load center. Due to that, the main advantage is that transmission cost is minimized and transmission line losses is also minimized. That is I square R losses. I square R losses. And the output can be controlled flexible, extremely flexible. Actually, in the nuclear power plant, they have taken n number of the safety precautions because it releases for the radioactive substances. Due to that, in this, the nuclear power plant, the power plant operation is automatic operation. The power plant operation is automatic operation. Due to that, the output we can control for extremely flexible. And it requires less supervising staff. Actually, comparing to the thermal power plant, in nuclear power plant, the less staff is required and the operation is very, very reliable. These are the various advantages of the nuclear power plant comparing to the other conventional power plants. Now you can see here, that is the amount of fuel requirement is quite small. That is comparing to the thermal power plant, here the fuel requirement is very, very less. We are applying the little bit of fuel in terms of gram, but in the thermal power plant, we need to supply in terms of tons. Just we are applying little bit of the fuel, we are generating the huge quantity of the power comparing to the thermal power plant. And the nuclear power plant, the less space is required comparing to the other conventional power plant, that is either thermal power plant or hydro power plant. Because in thermal power plant, the space requirement is more because we need to store for the coal storage plant and coal handling plant in the coal pulverization mill. That is the lump size or big size, the crush into small pieces and then powder. That is low graded coal also we can utilize for the more efficiency. For that purpose, the land requirement is more in the thermal power plant. But in the nuclear power plant, the land requirement is very, very less because the fuel utilization is very, very low. And the running cost is also less. That is the low running charge. The running charge in the sense, suddenly the demand is increased. Again, the fuel utilization is maximum in the thermal power plant. This problem is not occurring in the nuclear power plants. And it can be located nearer to the load center. Due to that, the advantages is the transmission cost is minimized and transmission line losses is also minimized. And no need to bother about huge quantity of the water is required. But in the thermal power plant, the quantity of water is more comparing to the nuclear power plant. But in the nuclear power plant, the water requirement is less. And large distribution of nuclear fuel is available all over the world. That is actually the uranium and then the thorium, the plutonium is available for the huge quantity to generate the power. But the major drawback is it affects the environment due to the radioactive substances. Now, what are the drawback in the nuclear power plant? Actually, in the nuclear power plant, the major drawback is the initial cost, otherwise the capital cost is more. The initial cost or capital cost is very, very high comparing to the other power plant, and the fuel cost is also more. The fuel cost is also very, very high comparing to the either thermal power plant or diesel power plant, the gas power plant. Actually, the fuel cost is very, very high. Initial cost is more, and another one, the fuel cost is more. And one more major drawback in the nuclear power plant, at the time of erection and the operation, highly technical person is required. That is, highly skilled person is required. Highly skilled person is required, because at the time of construction itself, we need to take for n number of the safety precautions. Because if the nuclear power plant, it releases for the radioactive substances, due to that, all the living organisms affected for the long duration. The long duration, the effect it will be presented for 100 to 500 years and prolonged up to 1000 years also. And if the any accident it should be taken place, means the surrounding 30 to 40 kilometers or more than 50 kilometers, the peoples are affected. To avoid that one, at the time of the construction itself, they are taken for n number of the precautions, n number of precautions to avoid to without leakage of the radioactive substances. That is nothing but radiation hazards. That is alpha rays, beta rays, and then gamma. If the little bit of the any radiation is entered into the open atmosphere, the complete the surrounding it should be affected. For that purpose, at the time of the construction and after the operation of the power plant, required for the highly technical person is required. Highly technical person is required. Due to that, the salary staff is increased in the nuclear power plant. Due to that, for all persons required only for the technical known persons, due to that, the salary bill is more comparing to the remaining power plants. And required long time for construction. The construction period is more comparing to the thermal power plants. Comparing to the thermal power, it takes the 8 to 10 years period. It takes 8 to 10 years period. Why here the construction time is taken more means, here the each and every stage, the inspection, the auditing is there. Once they are given for the approval, everything is okay. There is no problem in future. After that, we will be go for the next stage or the next step. Due to that, the construction time period taken is more. And the major drawback is the wastage disposal, the radioactive substances, we can place into deep trench. We can place into the deep trench. After that, we can send it to the away from the populated place, away from the human being, away from the human being. Suppose if it releases for the radioactive substances, it polluted to the environment, that is soil, water particle, the land surrounding the grass, human being, everyone is destroyed. The complete, the whole, it should be destroyed. These are the major drawback in the nuclear power plant. That is the fuel. The fuel used is expensive. In the nuclear power plant, the fuel used is expensive, is difficult to recover, is very difficult to do the recover. That means once the fuel is burning, means after that we can't reuse that fuel. Suppose if you go for the renewable energy sources, the recycling process, but in the nuclear power plant, the major drawback is the fuel cost is more comparing to the other conventional power plant. In the thermal power plant, the fuel cost is very cheap. But in nuclear power plant, that is the fuel we are using is uranium, thorium, and then plutonium. The fuel cost is very high, and the capital cost and initial cost of the nuclear power plant is high comparing to the other conventional power plant. Why here the initial cost is more means? Why here the initial cost is more means? In the nuclear power plant, at the time of erection, the various precautions are taken. Due to that, the highly skilled persons are there. Due to highly skilled persons are available. For that purpose, the more initial cost is happen. That is, the initial cost is high. And another one, the erection and commissioning of the plant requires great technical known persons. That is, at the time of construction, technically the skilled person is required. Each and every stage they are having for the inspection, the auditing purpose. They are tested the each and every stages. Once they are given for the approval, after that they will be go for the next stage. Due to that, the salary bill of the technical persons for all the places is high. And the fission byproducts, once it is burning means it releases for the radioactive substances. It is very dangerous. It polluted to the environment for both living as well as for the non-living organism. And the dumping, the wastage particles, send it to the away from the human being is also very, very difficult. These are the various drawbacks of the nuclear power plant. And the selection of site of the nuclear power plant, these are the various selection of site of the nuclear power plant. Availability of water. Actually here, sufficient the water is required for the cooling purpose. That is, the water is, the plant can be located where ample quantity of water is available. That is, the ample quantity. The ample quantity in the sense, the sufficient quantity of water is enough. But in the thermal power plant, the huge quantity of the water is required. In the thermal power plant, the huge quantity of water is required. But in the nuclear power plant, the ample quantity of wherever the water is there, at the particular places we can construct it for the nuclear power plant. This water is used for the coolant purpose for heat exchanger to convert the steam as well as for the coolant purpose. The water is required in the heat exchanger. Distance from the populated area. Actually, the thermal power plant can be constructed away from the populated area because it releases for the radioactive substances without affecting for the human being. For that purpose, the nuclear power plant can be constructed far away from the consumers, and nearest to load center, Actually, the thermal power plant and the gas and diesel power plant can be constructed nearer to the load center, but in the nuclear power plant, somewhat away from the load center, because if any accident is occurred means, if nearer to the load center, the transformer and circuit breaker, this all are again affected. Due to that, the accident is more. To avoid that one, the nuclear power plant can be constructed somewhat away from the load center. That is, not as far as possible be located. That is, somewhat little bit away from the load center. And disposal of waste. This is the major parameter. Actually, once the uranium is burning, the wastage in the form of radioactive substances that collected in the deep trench in the particular power plant, every yearly once or twice a year, collect again that from the deep trench, the radioactive substances collected in a barrel that send it to the away from the populated area, away from the human being. And the transportation facilities, comparing to the thermal power plant, in nuclear power plant, the transportation is very, very less. That is, the fuel requirement is very, very less. Little bit of fuel we can generate the huge quantity of the power. But at the time of construction, the large quantity of the materials is required. Large quantity of the material is required. That is, nuclear reactor, heat exchanger, the turbine, the condenser, alternator, so on, etc. That is, the good transportation facility is required both for roadways as well as for the railways. These are the selection of site of nuclear power plant. That is, ample quantity of wherever the water is available at the particular places we can construct the nuclear power plant, and somewhat away from the populated area, as much as possible somewhat nearer to the load center, and the parameter plays a vital role, disposal of waste, that is nothing but the radioactive substances. And the good transportation facility is required for both roadways as well as for the railways. And in the nuclear reactor, there are three functions happen. One is nothing but the fission process, another one is nothing but the fusion process. Nuclear fission, another one is for the nuclear fusion. And one more thing, that is nothing but the chain reaction. Actually, the fission means the splitting of heavy nucleus into two or more small nuclei is called nuclear fission. That is, the splitting of heavy nucleus into two or more small nuclei. Nuclear fission is nothing but the splitting of heavy nuclei into two or more the small nuclei. Small nuclei is nothing but the nuclear fission. Now, you can see here, this is nothing but the uranium-235. They are adding for one small neutron. Uranium-235. They are adding for the small slow neutron, we are getting that is the unstable uranium 236. Unstable uranium 236. That is the splitting of this is nothing but the heavy nucleus into two or more the small nuclei is nothing but the nuclear fission. Now this is bombarded, the nuclear fission is taken place. Now the splitting of the two small nuclei, one is nothing but the lanthanum, another one is nothing but the bromine, and it releases for the three small neutron, and releases the radioactive substances, that is nothing but the gamma rays, and then enormous the energy is released, and gamma rays, alpha rays. And one more the possible division is there. Again it is splitting of the, again this is the heavy nuclei again splitting into two nucleus. Again it releases for the, again one lanthanum, another one is for the bromine. Now nuclear fission means that is the splitting of heavy nuclei into two or more the small nuclei is nothing but the nuclear fission. In this the schematic diagram, the uranium 235 is there. Here we are adding for one the small neutron, that is the uranium 235. We are adding one slow neutron, that is it should be in the form of uranium 236, that is the unstable. Now the fission process is taken place, that is bombarded, it splitting into the heavy nuclei into two small nuclei, that is the one nuclei is nothing but the lanthanum, another one is for the bromine, and releases for the three small neutron, and it releases for the alpha rays, beta rays, and then gamma rays, that is uranium 235 we are adding for one the small neutron, we are unstable uranium 236, the splitting of heavy nuclei into two or more small nuclei. The small nuclei is nothing but, one is nothing but the lanthanum, another one is for the bromine, plus it releases for the three small neutrons. Now according to the mass equation of the reaction, that is the uranium, the value of the mass equation is 235.14. As per the mass equation of the reaction, the uranium value is uranium 235, that is 235.124. The neutron, the value is the single neutron 1.009. In mass equation, the lanthanum value is 147.961, and the bromine the value is 84.938, plus the three small neutron, that is 3 into each neutron the value is 1.009, that is each neutron the value is 1.009. Three small neutrons are released, that is 3.027. Now this the fission product, comparing to the right hand side, this is nothing but the left hand side and then right hand side. Here the value is 0.207 AMU, 0.207 AMU as per the mass energy relationship, Now comparing to the left hand side, the value is very small, that is energy equivalent released is 0.207 AMU. That is 1 AMU is nothing but 931, that is 1 AMU, the constant value is 931 mega electronic volts. Now the substitute this value, that is 0.207 into 931 mega electronic volts. And what is the value of the mega? 10 to the power of 6. 1 mega in the sense 10 to the power of the 6 is represent for the mega, and 1 electronic volt is represent for 1.6 into 10 to the power of minus 19 joules. 10 to the power of minus 19 joules. Now substitute the value 0, the value 193 mega electronic volt, that is 931 into 0.207, 193 mega electronic volt, that is 1 mega in the sense 10 to the power of 6, and 1 electronic volt is 1.6 into 10 to the power of minus 11, 10 to the power of minus 11. Now finally we are getting 3.08 into 10 to the power of minus 11 joules or watt second. This is nothing but the nuclear fission, and the next one, nuclear fusion. Nuclear fission means that is the element having higher as well as the lower mass number would be transferred into element near the center. Thus the huge amount of the energy is released. Now you can observe here, this is the two heavy hydrogen element, the H12, too heavy, the hydrogen element, the H12. It produces the helium atom. It produces the helium atom. Now that is here, lower as well as the higher mass number, transfer into the element nearer the center, and it produces for the huge amount of the energy released. Now the huge amount of energy is released means that is the two hydrogen atom, it releases for the heavy element helium and releases for the small neutron. And the hydrogen, the mass energy relationship, the value is 2.01473, and same the hydrogen, the helium value is 3.016697. In exam point of view, remember that is the number, the number is nothing but the starting value, and the neutron, the value is 1.009. Here also we are comparing for the energy equivalent. Comparing to the left hand side, the right hand side, the value is 0.03003,483 AMU. 483 AMU. Now you can observe here, that is 1 AMU is nothing but 931 mega electronic volt. Now we are multiplying 3.2426 mega electronic volts. Finally we are getting 1 mega means 10 to the power of 6. 1 electronic volt is 1.6 into 10 to the power of minus 19. So finally we are getting the value is 5.188 into 10 to the power of minus 13 joule, or simply it is represent for watt second. This is nothing but the nuclear fission. That is the lower as well as for the higher the mass value, you can transfer into the center point. Finally it produces for the huge amount of energy. The huge amount of energy. Here the two hydrogen element releases for the helium. And the last one is nothing but the chain reaction. Now the uranium-235 are adding for the one small neutron, uranium-236 bombarded, it releases for two small nuclei. One is nothing but the lanthanum, another one is for the bromine, and releases for the three small neutron. Again it is adding for the one, the uranium-235. Again it is bombarded, it releases for the three small neutron. The same process it should be continuous. That is the nuclear, the fission, the heavy nucleus split into two or more similar nuclei, bombarded by slow moving neutrons. Due to that, the slow neutron, it releases for the, due to this 10 number of the releases the neutron. Due to that, we are generating for the huge amount of energy. We are using the little bit of the fuel. Due to that, we can generate it for enormous amount of power. This is nothing but the chain reaction. It is one uranium-235. We are adding one small neutron. We are getting for unstable uranium-236, and bombarded we are getting two small nuclei. One is nothing but the lanthanum, another one is for the bromine, and releases for three small neutrons. Again here adding uranium-235. Again the process is continuous. Again here 3 is there. Multiply 3 into 3. That is 9 neutrons are released. Again into 3, 27 neutrons are like that. This is nothing but the chain